This is Intro to Proofs, section 3.5, and we're doing progress check 329. So here we're doing kind of set notation roster method, putting it all together. So here we're being asked to use set notation, the roster method, set builder notation and roster method to specify the set B of all integers congruent to 2 modulo 3. Okay. So their example is, so B equals, so we use the first type of set builder notation we learned, which is when you have a set and then a condition, such that n is congruent to 2 modulo 3. Okay, and then let's use the roster method. What are some numbers congruent to 2 modulo 3? So we'll put 2. 2 is always congruent to itself. Okay, and then plus 3 is 5, plus 3 is 8, plus 3 is 11. And you can see the picture there. And then we're going negative. There's -1, -4, dot. Make sure you have your dot, dot, dots on both sides because it goes both ways. All right. Square 5 different integers from set A. For each integer A that is used, determine R so that A squared is equivalent to R mod 3. Okay, so A were things that are equivalent to 1 mod 3. Okay. So square 5 integers from set A. All right. So A, so this is part B of my problem. So let's pick -5 squared is 25. Okay. And that is equal to 3 times 8 plus 1. So it's in A. So -5 squared is in A. It's equivalent to 1 mod 3. Okay, because it's 1 more than a multiple of 3. And then -2 squared equals 4, which is in the roster method already, so we know that's in A. And 1 squared equals 1, which is in A. And 4 squared is equal to 16, which is equal to 3 times 5 plus 1, so it's in A. And 7 squared equals 49, which is equal to 3 times 16 plus 1. So that's an element of A, right? All 5 things from A, when we squared them, are also in A. Part C, or part number 3. Square 5 different integers from B, determine the remainders. Okay, so things from B. So we've got several examples. So let's start with -4. -4 squared equals 16. We already showed that was an A. Okay. -1 squared equals 1. That's an A. 2 squared, that's 4. That's an A. 5 squared, that's equal to 25. We already established that's an A. And let me pick for convenience. So -4 is in B. And then -3, that's -7. That's 49. That's also a number I've already established is in A. So 5 numbers from B, when I square them, I get an A. All right, now multiply an integer from A times an integer from B. Read this several times. So then what sort of set do they end up in? Well, if I take, let me write down A up here, just so that you should have your book in front of you, so you should have A too, but it'd be nice to have the roster method, so I have some examples. -8, -5, -2, 1, 4, 7, 10, okay, so let's do a couple. How many are we supposed to do? So if I do -2 in A times -1, -2 times -1, that's equal to 2, which is in B. And then if I do -5 times -1, that's equal to 5, which is in B. And if I do, how about 4 from A times 2 from B, that's equal to 8. That's in B. Okay? Oh, I'm sorry, you can't see that. So, suspiciously, they're all in B. Okay. These activities should provide examples of general results taken so that basically this is setting up all the examples so that you really believe theorem 330. All right. Thanks for doing that progress check.